Hey everyone, we're going to take a look at number 7 here in section 7.1. We're going to evaluate this um indefinite integral using integration by parts. Here's the integration by parts formula again. So the integral of u dv is uv minus integral of v du. So what would we choose u to be? Remember our acronym for choosing u is Lyautey. And L is the first choice, which is logarithmic function. There's no log function there. I is inverse trig. We have a trig function, but not inverse trig. A is algebraic, and we really don't have a algebraic. Now you might say, well, you've got the 4x. You don't want to choose, your u to be the negative 4x because it's inside the e to the u, function. That would be like you were doing just a regular substitution method. You would do that. So we're not going to choose u to be that. We're looking at either the choices are what e to the negative 4x or sine of x. Well, that leaves me with t and e. T is trig, e is exponential. So those are the worst two basically we could take, but we're stuck with it. So I'm going to go ahead with t for trig and choose my u to be sine of x. And that leaves my dv to be e to the negative 4x dx. Here we differentiate. Derivative of sine of x is cosine of x. So I get du is cosine of x dx. Here I have to integrate, and I've got to be careful. There's a little substitution. The antiderivative of e to the negative 4x, right? I can let u be negative 4x, or let's say instead of u, let's say w, not to confuse it with the u over here. W is negative 4x, so the dw is negative 4 dx, and we get negative 1/4 dw is dx. And so we have this negative 1/4 from that relationship, right? So the antiderivative of e to the negative 4x is negative 1/4 e to the negative 4x, so be careful about that. Okay, so now we're ready. We've got our integral here is what? It's uv sine of x times negative 1/4 e to the negative 4x. We can write that way. Minus v du. So v is here, and this is cosine of x dx. That's the du. So let's clean this up a little bit, right? This will be what? Minus 1/4. We can pull out as a constant multiple. Negative times negative, positive 1/4. And I'm left with e to the negative 4x cosine of x. Now, we look at this, we look at the integral we started with, doesn't seem like we got anywhere, right? Because that's the same, and we've exchanged the sine of x for a cosine of x. Not a good exchange. Okay. So you might be thinking it's hopeless to do anything that's not going to work. Well, hold on, let's try this one more time on this. Let's do integration by parts again on this. Again, I'm going to choose u to be cosine of x. So the derivative this time of cosine of x is negative sine of x. The dv again is e to the negative 4x, which as we said before makes v negative 1/4 e to the negative 4x. So now we've got, again, the integral of u dv is uv minus integral v du. So uv is, so we've got copy this down here, plus 1/4 times the antiderivative of this, which is uv. So there's that, u times v, minus v du. So here is the v and here is the du. And if I clean all this up, notice I've got a negative 1/4 and a negative here, makes it positive 1/4, pulls that out, becomes negative 1/4 e to the negative 4x sine of x, so the integral of that. Okay. Now let me just clean this up one more time. This 1/4 here, which is in front of here, everything in brackets is the antiderivative of this. I need to distribute this 1/4 through. And when I do, so here's my original integral. I get negative 1/4 e to the negative 4x sine of x. 1/4 times negative 1/4, negative 1/16 e to the negative 4x cosine of x. And then 1/4 times, uh, be careful here. This we said is negative 1/4 e to the negative integral e to the negative 4x sine of x dx. So 1/4 times negative 1/4 is negative 1/16 times this integral. And you look at this integral and what we started with, and you say, hey, we're right back where we started from. Okay. So did this not work? Did this fail? Well, it actually worked because I'm going to call this integral. This is what we're looking for. What's the antiderivative of this? What is the antiderivative here? So let's just call this whole integral I for integral. And here we see the same integral. I'll call that I. So this will be I equals something minus 1/16 I. Notice I can solve for I by adding 1/16 I to both sides. And what is I plus 1/16 I? That's 16/16 plus 1/16. That's 17/16 I is equal to this. And I can solve for I by multiplying by the reciprocal 16/17 times all this stuff. And that's going to be my integral. I can add, I guess, a plus c. We can clean this up a little bit because I can distribute this 16/17 through. And when I do that, right, we get negative 4 goes into 16 4 times negative 4/17 e to the negative 4x sine of x. And then this times this, the 16s cancel, and we're just left with negative 1/17. Um, e to the negative 4x cosine of x plus the c. So there's what I would be happy with. You can also factor out a negative 1/17 e to the negative 4x and be left with 4 sine of x plus cosine of x. I think this is the way you achieve when I was doing the problem listed the answer to be, but this would be fine with me as well. Okay, hope this is clear and helpful.